Hi, I'm Peng, the machine learning data scientist at BlackRock. I'm going to talk about today is a really interesting work we were doing at BlackRock about anonymizing and mining survey comments using NLP technology, lexical chaining approach. So first, a little background. At BlackRock, we run many surveys, such as employee opinion surveys, to better understand employees' concerns and ideas and to better serve our employees internally. Our business goal is to build a scalable, efficient, and objective text summarization automation system. Or to be specific, we are aiming to build such a framework to extract and summarize several themes from survey comments accurately. The survey comments are plain text, totally unstructured data. While there are challenges such as, firstly, the comment survey, they tend to be very short. And secondly, survey comments do not have a lot of content. Thirdly, people have multiple ways to express the same idea. Fourthly, there are multiple ideas expressed in a single sentence. And lastly, there are typos and errors. For the next, we are going to talk about our methodology and our NLP stacks. Our theme extraction is based on fundamental knowledge, includes word embedding and NLP downstream models. And also our text processing pipeline includes language detection, sentence segmentation, spelling correction, tokenization, lemmatization, de-identification, chunking, and lexical change. I will introduce our methodology and the algorithm of each node one by one. The base Nlp layer consists of two components, Nlp downstream models and word embeddings. The Nlp downstream models represent the syntactic knowledge in the text, and we use Nlp models for various text processing steps. We not only use Python libraries include Spacy, NLTK, TextBomb, but also we train the model in-house, such as Tokenizer and the de-identification model. Both of them are built specifically for internal NLP use. Word embedding represents the semantic knowledge in the text. The method we use to do word embedding is word-to-vector. We build a word embedding model using word-to-vector based on open-end response from survey data from 2016 to 2020. And we utilize a word embedding to find semantically similar concept to aid in building lexical chains. The text processing is heart of our NLP stack. We apply several modules to process the text to help us understand the data. Text processing, as we discussed, consists of 8 modules here: language detection, sentence segmentation, spelling correction, tokenization, lemmatization, de-identification, chunking, and lexical chains. For language detection, it may computer recognize the text or string we process is English, and at the same time, we will decode the string in UTF-8 to ASC to II to filter out few non-English characters. For sentence segmentation, we use a sentence tokenizer from Spacy. Well, beside of it, we also segment a sentence by splitting on new line characters. We do it so concepts do not overlap between sentences. For spelling correction, we used TextBomb for spelling correction. The algorithm behind it is to check each character in the text, what is the most likely correction by deleting, transposing, and inserting characters. For tokenization, we use in-house built tokenizer, which we name it as Air Tokenizer. Like other popular tokenizer, Air Tokenizer inherits from Peng tree bank tokenizer, whose algorithm is based on regular expression. But the difference is tree bank tokenizer can only chunk a text at spacing along with punctuation. Air tokenizer can not only chunk at a space, but also chunk in the middle of a word. So in this way, we recognize and correct a missing typo, which is quite common in employee opinion survey. Comparing with other missing space typo correction package on the market, Air Tokenizer performs better in our NLP tasks because it also takes background common phrase possibility in consideration beside of the splitting a low frequency word into high frequency words. So in technical, by Air Tokenizer, we reduce the EOS word dictionary size and we stop the feature dilution from tokenization. Lemmatization is a process gathering forms infected of a word so that they can be analyzed as a single item. The lemmatizer we use here is from Spacy. The de-identification is one of the most important process in our pipeline because there are many person identifiable information data related, such as employee's name and locations in employee opinion survey text. In order to protect these personal identifiable information data, we build a de-identification system to recognize and anonymize them. The de-identification system includes two models. One is a dictionary-based de-identifier, which consists our employees' names, employees' location, and the other one is a name entity recognition system-based de-identifier, which is built by LSTM CRF model. For example, here's a scenario. When we see Atlanta, Atlanta will hit a key of location dictionary. So we replace word Atlanta by dummy word location generally. Well, there are a huge number of cases that entity like location are mentioned not in formal spelling. There are many other ways to say Atlanta like ATL for short. In this way, we cannot match ATL to any word in the dictionary. In this circumstance, we need to train computer to recognize ATL as a location by content. By LSTM CRF neural network will make it recognizing an entity not only by spelling, but also by content ahead of it and behind it. The next node is chunking. Chunking is dividing sentences into non-overlapping phrases and extracting them from sentences. Chunking group adjacent token into phrases on the basis of their post of speech text. We use Spacy non-phrases chunker to extract non-phrases in the text. So for example, when we see the tokens in process text like BlackRock, founder, culture, and we know these are non-phrases and they are adjacent to each other, then we can concat them together as one token. And when we came across the four principle, and we know they are adjacent to each other, and both of them are non-word, so we can concat them together as one token. Then we move to lexical chains model. Lexical chaining is a process of connecting semantically related words, creating a set of chains that represent different threads of cohesion through the text. Lexical chains capture the lexical cohesive structure of the text. So, for example, in survey comment, when we see culture, founder culture, inclusion, diversity, these concepts, we will chain them together into one theme about culture. And when we see principle, one BlackRock, passion, fiduciary, innovator, these concepts we will chain them together because we know they are a different aspect of our BlackRock principle. The process of building lexical chain from processed text can be understood as, for each token in processed sentence, we check each concept in the existing lexical chain. If token and concept are the same, increase the count of the concept in the chain. Then, if the token and concept are related, add the word to such lexical chain. And for the L that token are not in lexical chain and is not in the related concept, we create a new lexical chain. And here we find the semantic relatedness among the set of sense according to its representing determined by the word embeddings we built earlier. After we build the lexical chain, here as you can see, this is a workflow about the SIM extraction. We score each chain by its length and also the frequency of each concept in the chain. According to the score of the chain, we will prune the weak chains, and besides, according to the semantic relatedness, we collapse related chains. So in summary, we automatically process the open-end response data, de-identify it, and extract themes. And secondly, we utilize in-house developed tokenizer to build a handle tokenization. And thirdly, we anonymize the data using a hybrid rule-based and also a machine learning approach. And fourthly, we extract the themes post-processing lexical chains. And next, we can handle short text data better and assign themes for each comment based on its content. And lastly, our approach enable and help us to capture various lexical variants of a concept and tag each comment with multiple themes. That's it for us, and thanks for listening. And if you have any questions, please feel free to ask. Thank you.